Next up in our talks is Simona. She's going to be talking on a dive into the visitor's design pattern. Over to you, Simona.
Hello, my name is Simona, and today I'm going to talk about the visitor design pattern. More explicitly, we're going to look into what it is, what problems it solves, and its implementation. The visitor design pattern is a behavioral design pattern that allows the addition of new operations to existing object structures without having to modify the objects themselves. In order to better understand it, we're going to look at a hypothetical scenario. Let's imagine that we work for a multinational bank which offers 3 types of credit cards: bronze, silver, and gold. These credit card options have been introduced a long time ago, and the code base that handles operations for them is already in place and used throughout the banking system. We have been tasked to develop some new pieces of functionality. The bank signs new contracts with 3 new companies: a hotel, an airline, and a gas station, based on which they will offer cashbacks to customers that use their credit cards. Now, our job is to design these new pieces of functionality. The question is, how would we go around to implementing these new features? Let's first take a look at the most simple yet not so efficient way. We have discovered that each type of credit card is represented by its own class, and they all implement the CreditCard Interface. The first idea that comes into our minds would be to add the methods in the CreditCard interface and then implement them in the corresponding classes. This way, we will compute each type of offer inside the credit card implementations. The problem that we will encounter is that as we add more operations in the interface class, we also need to add them in all the classes that implement the interface as well. This causes a lot of unnecessary disruption and can be quite dangerous. Although this method is the simpler one, we need to consider how it affects us. By handling logic focused around external offers, we are tightly coupling 2 different concepts: the credit card and the offers, reducing our flexibility and reusability of the code. Moreover, we are also violating the open-closed principle that says that we should keep our objects open for extensibility but closed for modification. We also need to keep in mind that the credit card classes are used by downstream components in this context, which can be affected by the changes. Overall, this change could make the code base difficult to maintain and test. This is when the visitor design pattern becomes useful. For simplicity purposes, we're going to look at a general design first. Looking in the right-hand side of the diagram, the visitor interface defines visit methods, which take as parameters the concrete element classes. The visit methods are then implemented in the concrete visitor classes, which will contain the pieces of functionality that the elements require. So instead of having these pieces of logic coupled with the element classes directly, as we've seen previously, they will be isolated inside the appropriate concrete visitor classes. Looking at the left-hand side, we have the element interface and the classes that implemented and require the new functionality. The only change we need to make here is to add an accept method. The accept method takes in a visitor object, and from there on, it's the visitor's responsibility to make sure the correct method is used based on the element type. Inside the accept method, we're going to call the visit method and pass a reference to the current object. Let's now dive into the implementation of our credit card problem in code. For demo purposes, the classes don't contain any logic besides printing some strings to the console. First, let's analyze the Offer Visitor interface. This contains visit method definitions for each type of credit card, bronze, silver, and gold, which will be implemented accordingly in our concrete visitor classes. We are abstracting operations for each type of credit card here and then implementing them based on the types of offers. Remember that we have 3 types of offers: the gas offer, hotel, and airline offer, which, based on the type of credit card, should output a different result. Let's now take a look at the implementations of this interface, the GasOffer Visitor. The GasOffer Visitor implements the Offer Visitor interface and defines logic for handling gas offers on credit cards. Each visit method takes a bronze, silver, or gold card and outputs the corresponding offer. Similarly, the HotelOfferVisitor handles how hotel offers are being outputted for different credit cards. This plug-and-play power that the pattern offers us leads to great flexibility in terms of what functionality gets added and what functionality could get removed without actually modifying any of the credit card classes. Here we have the CreditCard interface. As mentioned before, the only change we need to make is adding the accept method, which takes in an OfferVisitor object. The idea behind the accept method is that the credit card classes accept visitors and let the visitors call the right visit method based on the type of credit card and the type of the visitor. When implemented, the accept method is going to call the visit method by passing a reference to the current object. So each card class passes their own reference to the visitor, which handles the appropriate call. In order to test it, we create a few credit cards and one of each type of the OfferVisitor implementations. All we have to do now is just call the accept method on a credit card instance and pass one of the gas, hotel, or airline OfferVisitor as a parameter. As we can see, this outputs different offers based on which credit card and visitor offer implementation we used. Here we highlight the relationships between the different classes within our credit card solution. We can see the OfferVisitor interface, which defines the visit methods based on each type of the credit card and the concrete visitors being implemented in the form of the guest, airline, and hotel offer visitors. They all compute various offers for all credit types. As well as that, the credit card interface defines the required accept method, which is then implemented in the credit card classes. Now that we've seen the visitor design pattern in action, let's glance over some of its pros and cons. Some of the pros include the fact that it's easy to add new operations to objects without modifying them. Moreover, related behavior is focused in a single concrete visitor. For example, all operations that handle gas offers on credit cards were found in the GasOffer Visitor class. As well as that, it implements double dispatching in languages that don't support it natively, such as Java, which only supports single dispatch. Some of the cons on the visitor design pattern are the fact that the visitor can modify your elements, since an instance of the element is sent to the visitor. That is not recommended as it can lead to side effects, but it can be fixed by making the element objects immutable. Moreover, the code of the element objects is spread out in all the visitor objects. Therefore, the element's logic lives in many classes. It makes the code harder to read if you want to look at the code for a specific element object. And finally, it requires a new visitor class for every action, as we've seen with our offers. That would be all from me.
Thanks very much, Simona. Well done. We'll head over to the questions that have come through on Slido for yourself. First question, how did you find out about the pattern? And what advice would you give to someone looking to learn more complex coding in Java?
Well, the first time that I found out about the pattern was at my last job. One of my colleagues showcased an actual use of it when solving a problem. It's not a very common pattern. I would say it's not that commonly used in the industry. There are a lot of free resources out there for learning more about design patterns. There are some books as well. I could compile a list and send it to whoever is interested as well. But I'm still learning just like everyone else. So this was just a small share of what I found interesting. And yeah.
Cool. Thanks very much, Simona. Second question was, are there any other patterns that you found useful so far?
I guess some more common used ones, such as the builder pattern, it's quite commonly used. The factory pattern is also quite commonly used. The thing is, for example, with the builder pattern, Spring Boot is already taken the place in replacing a lot of the manual work and just letting you use annotations instead of doing the actual work yourself. But yeah, I would say those are some of the most common ones.
Brilliant, thanks. Someone's asked, sorry, I'm new to development. What's double dispatch, please? If it's too complex to explain, I'll Google it.
No, it's fine. So by default, Java supports single dispatch, which is pretty much similar to polymorphism. So, for example, if you'd have an interface and you have two classes that implemented, and let's say if you have an animal interface and you have a dog and a cat, and then you create two animals, one instance of a dog and one instance of a cat, and they have a method called make sound, for example. At runtime, the JVM has to decide which method is appropriate for that element, because they both are of type animal, but they each have their own implementations of a specific method, let's say. But the compiler will know which correct method we'll have to call. In the case of a double dispatch, there are two factors that need to be taken into consideration during runtime in order to decide which method to call. So in our case, the correct method call will depend on the type of the credit card and the type of the offer visitor. So that refers to having two levels of two dispatch levels, which is not by default supported by Java. It is supported by other languages, I think, such as Scala, Lisp, but not by Java. And this pattern allows you to make use of that, if that made any sense. It's a bit hard to explain without actually seeing it.
Oh, very good. Thanks, Mona. And finally, message from James. Not actually a question. James says, no question. Just want to say, really interesting talk. Well done.
Oh, thank you.
Marvelous. Thanks for that, Simona.